Hi, I'm Phil, and today we're going to start a new course on electronics. And in week one, we'll be looking at electronic breadboards and an electronic CAD program called Tinkercad. So besides Tinkercad, we'll have a quick look at Frizzling, and both of those are electronic CAD programs. So what you'll learn on the course, you'll be able to identify electronic components. You can build a simple electronic circuit, and not only just with electronic components, but also it will include the microbit computer. We'll learn about electronic breadboards, and we'll be able to simulate an electronic circuit using Tinkercad. And part of our design, we'll be able to specify a bill of materials after we've designed our electronic circuit. So I'm recommending that you get hold of this book by Dahl. And I've called the circuits 1 to 9, Dahl circuit 1, Dahl circuit 2, and I've got the simulation of all of those on my Tinkercad website. If you can't get hold of the book initially, at least get hold of chapter 1, and it will tell you how to go about designing the circuits. So that's a free copy available from this website. Okay, so the tools are, we've got hardware, the electronic kit with all the components in it, the breadboard, and a multimeter. So these are the essential tools that you should use. Software-wise, we'll use Tinkercad, and you can go on and use the more advanced version from Autodesk called Fusion 360, or you can look at the Frizz software. Okay, components. We're going to look at very simple components to start with, and here are some of them. We've got capacitors on the top left and right, a battery, hookup wire, a resistor, and an LED. And these are the components that are good to identify and to start off with. So for the resistor, we need to learn the color code so that we can pick up the right resistor value. The resistor will be in ohms, and the color code allows us to pick up that resistor using this color code. So you can see it'll start off with the first digit, and this particular resistor on the top is 47k ohms. So just notice the ohmic sign for resistance. And it not only includes the value of the resistor, but it gives the tolerance, which is within plus or minus 5%. So if you can map the colors starting off from the left and moving towards the right, on the far right we have the tolerance. On the far left we have the most significant digit of our resistance. Okay, LEDs, we'll be using lots of these in our course. And the important thing to recognize here is that the longer wire lead is the anode, and it's connected to the plus sign, and the other one's called the cathode, so it has the shorter lead. So the light emitting diode we'll use it to emit light of various colors. And both the resistor and the LED are used in this very simple circuit, and that'll be the first circuit that we build. So here you can see the LED and the construction inside, and both of those diagrams have the long lead and the short lead. And we can represent those on a circuit diagram or a schematic. And we put the resistor in there because we have to limit the current through the diode can be no more than 20 milliamps. So a range between 10 and 20 is desirable. And we can calculate the value of that resistor by looking at the forward drop of the diode and deducting that from the power supply, and the maximum current being 10 milliamps gives us a resistance often around about, say, 470 ohms. And we'll be using diagrams to identify how the circuit works, but also to build our own circuits and design our own electronic circuits. So on the bottom is an example of a more complex circuit that doesn't take that long to build, but it's a simple electronic piano using the 555 timer. So you can see the resistors there. We've got no diodes, but we do have an integrated circuit, and that is the 555 timer. We have a speaker, and we have a battery and the capacitor. So there's our diode. More components. Here we've got the light-dependent resistor, and this is a resistor that changes its value according to the light. So we could use it as a light switch. And we've also got transistors. We'll be using two types, an NPN and a PNP. And that's what they look like. They've got three wires coming from them. And the middle one is the base. And the other ones are called the collector and the emitter. And there's even more components. There are hundreds of components, but these are the most popular ones. And there's these are the ones that we'll use for our circuit. So here we've got a speaker, or alternatively, we could use a cheaper buzzer if we just have an alarm. We've got integrated circuits, and one of the most popular ones is the 555 timer. And we've got push buttons. And all of these can fit onto breadboards. So here's my first breadboard. And I got this quite a long time ago. And it's housing the world's first microcomputer, a whole computer on a single chip that was used by General Motors in its engine control management. So that goes all the way back to 1982. And I've still got that circuit today, even though I'm supposed to remove the wires and reuse the board. But that's an example of a medium-sized breadboard. And this is my biggest breadboard. So you can see it's double the size of the previous ones. And I've got hookup wires and a couple of resistors already on the board with an LED. And this is the most elaborate breadboard I've got. It's got a Arduino Uno built inside. So when you connect to the pins, you're connecting directly with the Arduino computer. And that saves you a bit of time, and it makes the circuit a little bit easier to use. I will be using a smaller version of the breadboard, which has 400 contacts, and it's labeled with rows and columns. So you can see on the top we've got the columns A to J, and the rows are numbered 1 to 30. So this little breadboard is good enough to construct all the 9 circuits that I'll be looking at. And on the extreme left and right, there are power rails. So the red one, we connect that to a positive voltage, like 5 volts, or 3.3 volts for microbit electronics. And it's complemented with the black rail. So along those rails, there's a wire underneath the or inside the breadboard that connects all of the pins along that column. So if you want to connect to a voltage or a power supply, you just have to connect to one of those pins on those supply rails. And besides the supply rails, we've got the component areas on the left and the right. And in each row, we've got the same wire connecting across. So if you want to connect a resistor, but on the first row, you just connect that and it will automatically connect to all the other pins along the same row. So we've added a resistor, and now we've added an LED to the breadboard. And with our power supply, we now have a working circuit. And if we wanted to build an electronic piano with push buttons, we just simply put those push buttons between the left and the right area on the component areas on our breadboard. Okay, so let's go off to Tinkercad, and I'll explain first all the different areas on the page. And this is my copy, and I've got plenty of circuits already to show you. So this is an example of a LED with the resistor being powered by a 9-volt battery, and when we push the push button, it will turn on the LED. And I've also added a multimeter to measure the current in the circuit. So let's have a look at all the different areas. We've got the different types of LEDs that we can select, and their color code is here, and we can select those using the selection area on the LED menu. Okay, from Tinkercad, besides constructing the circuit, we can also show what its schematic looks like. And for that circuit, we've got the battery on the left, the resistor, the switch, S1, and we've got the diode. And we can also create a bill of materials. So for all those components, we can get someone else to purchase them, and they can construct that according to your design and test it. So there are plenty of components to pick from, and here I've added an oscilloscope, which is on the right, and a power supply that can give us other voltages, and that's on the left. Now, to get those other components, you go to the components area on the right, and instead of selecting basic, you select all the components. So you can see that I've got alternatives down here, and some of those extra components include actuators like motors, a 7-segment display, and even a 4-digit 7-segment display. We'll be using Grove electronics because that saves a lot more time, although it's a good idea to start off with. And our first few lessons will be on the breadboard, but we'll be converting across to Grove. And the reason is that we can construct the circuits a lot quicker. And Grove electronics uses modules. So I've got an actuator and a sensor connected to a power supply. So here there's a Grove DC jacket, and the actuator is a LED, and on the right we've got the sensor. And the idea of this circuit is when you press the button, the LED will go on. Just like the other, it functions just like the other circuit. And the Grove cables connect all the modules together. So you can use the microbit Bitmaker can be used to supply both the control signals and the power to our Grove modules. So the Grove cable actually has two parts. It has the power supply with the 5 volt, and that's the red wire. The black wire is the ground, and the signal 1 and signal 2 are the yellow and the white cable on the, or the wires on the cable. And the end is the plugs that go into the Grove module. So there's our Grove cable and how we connect it. And our microbit here has 2 ports, port 1 and port 2. And that's what we'll be using later when we specify our Grove electronic circuits. Now, some of the Grove components that we'll be using will be quite simple. They'll be either analog, digital, but there are more complicated ones that are using the I2C communications and the serial communications interfaces. So at the top, we've got a sensor, which is a Grove push button. And on the bottom, we have the actuator, and it is the LED Grove module. So you'll notice we've got sockets on both of those modules, and that's where we plug in, and you can only plug it in one way, so you can't get it wrong. And it's fairly quick to construct the circuit. And to give it a nice presentation, I use Lego wrappers and mount everything on a Lego base plate. So a more complicated Grove circuit is this one, and it was just released last week. So it's a complete camera, but not only a camera, but it has AI vision, and it's called the Grove AI Vision module. And it uses the I2C interface, and it can communicate with various microcontrollers from the Arduino, right through to microbit. And you could use this as a sensor for the microbit using the Bitmaker. Okay, another more complex module is the thermal imaging camera. And this particular one, on the bottom, you can see this chap going to the refrigerator, and the thermal image is shown on the left. So this is used for security applications where you want to detect if a human being is present in an area. And it's widely used in COVID-19 to detect if someone has a high temperature. So the most complicated Grove module that you'll get in the kit is the Grove 4-digit display. And unlike microbit, which scrolls messages across, this will show 4 digits. And you will use this later to construct a simple clock where we'll show the hours and the minutes together without having to scroll the time across on a simple microbit computer. And we would connect that module using the Grove cable to a microcontroller. So we'll go across and have a look at that, and we'll have a look at how you can access some of the circuits. Okay, so we've now got the Tinkercad webpage on my Chrome browser. So you just go up to tinkercad.com, and I've already got an account. So it's come up with my personal area, and I can choose on the left because I've set up classes, Chatswood Electronics, and I'll be putting some of the circuits in that area. But if you create your own account, you can do 3D design, circuits, or code blocks. And it's a good idea to explore all three of them, but we'll be using the circuits area. So if I click on circuits, it'll open up my circuits that I've been working on. And you can see I've got quite a number of them here. So if I want to look at a fairly recent circuit, we'll have a look at, say, one which is very simple, which is the dial circuit number 1. And I'm going to tinker with this one. I've already constructed it. And to get it working, we just simply start the simulation. So we've got various areas we can use on this CAD tool. We've got a construction area, which is the large area here, and we've got the component area on the right. So you'll notice that you can select basic components, or you can switch to all components. So under the basic components, you even get the microbit, you get the battery. And if you want one of those, you just bring it out. So you just drag it across to the construction area. And then you fill in the details on the form. So if you look at the color coding, it complies with what it says here. It's going to be a 1 k ohm resistor. If we wanted to change that to a 10, you notice the color will change. The color coding will change. And if you want to rotate that, or if you want, or put it on the board, first we'll rotate. So we'll just rotate it round, and we'll bring it in. So it'll go between the rows here, 26 to 30. So we've now connected it to our circuit. And if you notice that if you go down here, the actual red dot means that you can join a wire to that. So if I wanted to join a wire, I could move that one across, and I can join the wire from here to the positive supply rail. And on the bottom, I can join a wire to the other rail. Now, you might notice at the moment, I've only got the rail connected to the top supply line and not to the bottom. And what I would need to do is have additional wires that connect the ground on the top to the ground on the bottom. And I do the same with the supply rail. So we go from here down to top. Now, notice the color of the wire that's been selected. It doesn't comply with the standard. So I select the wire, and I can just change the color over here using the tools on the left. So that's going to be black. And the other one, we're going to select as red. Now, this sometimes happens. Best thing is just to terminate it and erase it. So you select it like that one. And instead of green, we're going to change that to red. So we've now got a very simple circuit. And if we wanted to simulate that circuit, we just start the simulation. And you'll notice that the LED here goes on. So the current is flowing from the positive. It's going into the supply rail here. And it then connects the LED to the resistor and completes the circuit with a return to the ground. So I'll publish some of the dial circuits on the classroom area. And to get into the classroom area, just simply use the nickname and the class code. And I'll let you have a go at constructing the circuits to start with, and I'll give you the circuits later on. So what we'll do now is just return to the presentation. See if I can find that presentation. And these are the circuits that I'll be publishing. Next week, we'll have a look at doing a name badge and coding on the microbit computer. So in addition to scrolling your name across on the microbit LED array, we'll also hook up some electronics. So you can, when you press buttons on the breadboard, you can scroll other messages across. And we'll do that next week. So here are some of my references. Strongly recommend the book, that you can start constructing the circuits in the book, and there are 9 quite good circuits there to have a go at. Only one of those circuits doesn't simulate on the electronic Tinkercad software. So go to Tinkercad. You can create your own account there, and there is a couple of other references that describe some of the other components. And if you want to learn more about the electronic components, the website Electronic Tutorials is a good one to start with. It'll give you some more background into how these circuits work. And for breadboards, if you want to go and learn a little bit more about that, look at the Wikipedia article on breadboards. And also there's an article from Seed Studio on breadboards. And that's it for this week. And we'll join you next week for making the name badge and connecting microbit and some electronic components to the breadboard.